Hi, Tim Unkert here. In this video, we're going to factor trinomials and binomials with a common factor. So let's look at this first example. We're factoring 4x squared plus 24x plus 32. One thing I noticed about 4x squared, 24x, and 32 is that they have a common factor of 4. That's the greatest common factor that I can divide out of each. So I'm going to rewrite this as 4 times x squared, because 4 times x squared will give me 4x squared, plus it's going to be 6x, because 4 times 6x will give me 24x, plus 8. The reason being is 4 times 8 is 32. So I factored out the common factor. Now I've got a quadratic trinomial that has a value in front of x squared equal to 1. So, and I have a plus 6 here and a plus 8 here, so b and c are both positive. So if it is factorable further from this point, I'm going to look at 8 and look at the positive factors. So I can multiply positive 1 times positive 8, and that will give me 8. I can also multiply positive 2 times positive 4, and that will give me 8. Now I want to find the pair of factors that adds to positive 6. And if I look here, 1 plus 8 is 9, so that's not going to work. But 2 plus 4 does work. All right? So I can rewrite this in factored form as 4 times x plus 2 times x plus 4. Okay, so I think I have my solution, but I should always check. So let's do a little check over here. Okay, so I'm going to take 4 times x plus 2 times x plus 4, and I'm going to see if I can multiply that back so that I get the 4x squared plus 24x plus 32. So first I'm going to do 4 times x. That's going to give me 4x. Then I'm going to do 4 times 2, which is going to give me the 8 here, so 4x plus 8. We're multiplying still times x plus 4. Now there's multiple ways I can multiply these together. One way I like to show students is through a Punnett square here. So let's draw a Punnett square. And we'll do 4x and 8 and x and 4 here. And if I do 4x times x, I get 4x squared. So we're going to multiply, so 4x and x meet in this box. So we're going to multiply them together. X and 8 meet in this box, so we'll multiply them together and we'll get 8x. 4x and 4 meet in this box, so we'll multiply those together and we'll get 16x. And then 4 and 8 meet together here. We'll multiply 4 times 8 to get 32. Okay, so we've got the 4x squared that we started with here, so that checks. Then I look for my like terms. So 16x plus 8x, that's going to give me 24x. Okay, so that checks. And then we've got the 32 here. So this here, 4 times x plus 2 times x plus 4, has multiplied back to 4x squared plus 24x plus 32. So this is the factored form. And we are done with our first example. Okay, in our next example, we are factoring a binomial. We have 6y cubed plus 18y. So the interesting thing here is both terms here have y in them, and both terms are divisible by 6. So in this case, the greatest common factor between the terms is going to be a coefficient, a number in front of a variable. Now, out of y cubed, I could divide a y and be left with y squared. So if I divide 6y out of y cubed, take out 6y, I'm left with y squared plus Now I'm going to divide 18y by 6y. So 18 divided by 6 is 3, and y divided by y is 1, so it's just 3 times 1, or 3. Okay, so I've got y squared plus 3. Now you really can't factor this any further. In my last example, I'll show you something with factoring complex numbers, but we're talking like I square roots of 3, y plus I square roots of 3 times y minus I square roots of 3. I'm just giving you a little hint ahead. We really can't factor this and get a real factors. Okay, so let's check this and make sure that this is the correct factorization of this. Let's do our check. So we're going to do 6y times y squared plus 3. And we're going to use the distributive property to check. So 6y times y squared is 6y cubed. 6y times 3 is plus 18y. And so we've gotten back to 6y cubed plus 18y. All right, in this next example, we're factoring negative 5x squared plus 10x minus 5. So all of these are divisible by 5, and actually we could divide out a negative 5. So we're going to do that. So we're going to take out the negative 5, and we'll be left with x squared, because negative 5 times x squared is negative 5x squared. When we divide a positive 10x by negative 5, we get a negative 2x. And then negative 5 divided by negative 5 is positive 1. Okay, so now we look at this. We've got negative 5 times x squared minus 2x plus 1. We've got a quadratic here with a equal to 1, the number in front of x squared. And we've got a negative b value and a positive c value, meaning that both of our factors of 1 that we list out here should be negative. So if we multiply negative 1 times negative 1, we will get positive 1, and it will add to negative 2. So, I want to select, that's really the only pair of factors I could select. So we're going to rewrite this as negative 5 times x minus 1 times x minus 1. And we've got x minus 1 times x minus 1, so we can, when we multiply something by itself, we can write that as that something squared. So we're going to have negative 5 times x minus 1 squared. Okay, we do want to check this. Okay, so let's take this, negative 5 times x minus 1 times x minus 1, and make sure it multiplies to negative 5x squared plus 10x minus 5. So we're going to do negative 5 times x minus 1 times x minus 1. And let's see. So I'm going to do negative 5 times x. That's going to give me a negative 5x. I'll do negative 5 times negative 1. That's going to give me a positive 5. And then we're still multiplying by x minus 1. All right, so let's do the Punnett square here. So I have negative 5x and 5. We have x and negative 1. Negative 5x times x is negative 5x squared. X times 5 is 5x. Negative 5x times negative 1 is a positive 5x. And then negative 1 times 5 is negative 5. So we've got the first term, the negative 5x squared. Then we'll combine our like term, so 5x plus 5x, that's going to give us 10x, and then we have negative 5. So it does check out, and we're done with that example. All right, with this last example here, we're going to go the distance, and I'll show you some complex roots here. So we're going to factor negative 12x to the fourth minus 48x squared. Now I noticed one thing off the bat, both of these are divisible by negative 12. So we're going to factor out a negative 12. And not only that, x to the fourth, you can divide that by x squared to get, well, we're just going to get x squared. And then negative 48 divided by negative 12 is positive 4. And x squared divided by x squared is 1, so 4 times 1 is just 4. Okay, so we factored out this negative 12x squared. That's the greatest common factor. Now, in terms of having real factors here, real number factors, we can't go any further. But if I multiply negative 2i times 2i, I'm going to get negative 4i squared. Okay, so I squared is, or I is the square root of negative 1. So let's write that down over here. So I is the square root of negative 1. When you square that, the square root, squaring a square root undoes the square root, so we just are left with negative 1. So we're left with negative 4 times negative 1, which is our positive 4. So long story short, we can factor this to negative 12x squared times x minus 2i times x plus 2i. Now, you may not be going that far. You may just go this far and stop. But if you're going for complex roots, you can go this far. Okay, if we want to check the real one, let's just do a quick check. We'd do negative 12x squared. We'd use the distributive property here times x squared plus 4. Negative 12x squared times x squared is negative 12x to the fourth. So that first term checks out. And then negative 12x squared times 4 is negative 48x squared. So the second term checks out and our solution checks out. Anyways, that's it for my video. Hopefully you enjoyed it and it was helpful. If it was and you haven't done so already, please like and subscribe. I hope to see you in the next one. Bye.